In this lesson, we're going to look at how to divide fractions. So to divide fractions, you're simply going to multiply the first fraction by the reciprocal of the second fraction. The reciprocal, remember, is flipping the fraction upside down, so the numerator will become the denominator, and the denominator will become the numerator. So in order to do this, I'm going to take a look at this first fraction. I'm going to copy down the 3 over 4, and I'm then going to multiply that by the reciprocal of the second fraction. I then, in order to multiply fractions, multiply numerators with numerators. So 3 times 5 is going to be 15. And then in the denominator times denominator, 4 times 2 is 8. These fractions have no common factors that will divide into each, so therefore this fraction is in simplified form. Looking at my next example, 9 over 8 divided by 15 over 12. I'm going to copy down my first fraction, multiply by the reciprocal of my second fraction. I then am going to multiply numerators with numerators. So 9 times 12 is going to be 108. And 8 times 15 is going to be 120. So I can quickly see that these are both even, so they're at least divisible by 2. I could also see that the sum of the digits in the numerator and denominator is a number that is divisible by 3. So these are also able to be divided by 3. If you want to check out my video on divisibility rules so that you can simplify fractions very fast, click on the link shown on the screen and that will take you to that video. So continuing on here, I'm going to divide each of these by 4 because I can see that the last 2 digits in each number are divisible by 4. So I know that each of these numbers is divisible by 4. And so if I reduce 108 by dividing it by 4, I will achieve a 27. 120 divided by 4 is going to be 30. And here's where I can see that they are divisible by 3. So I'm going to divide each of them by 3, and I obtain my final simplified answer of 9 over 10. But this is a slow way to simplify fractions, and it is better and more efficient to simplify before you multiply. So I'm going to do this example over again and show you how you can be a bit more efficient. So I'm going to again start off by taking the 9 over 8 and multiplying that by the reciprocal of the second fraction. I'm then going to factor each of these fractions, and I want to use numbers that are common to numbers in the numerator and denominator. So for instance, I'm going to take that 9 and I'm going to write that as 3 times 3, and I'm going to write 8 as 4 times 2. And the reason why I chose to write it as 4 times 2 is because I can take 12 and write that as 4 times 3. And then I can write 15 as 3 times 5. And now if I see a number in the numerator and denominator that are the same, they will divide to 1. So I can see that this 4 divides with this 4 to make a 1, and this 3 divides with this 3 to make a 1. I can then multiply my fractions. So in the numerator, 3 times 3 times 2 ones is going to be 9. And in the denominator, 1 times 2 times 1 times 5 is 10. In this next example, we're going to look at some fractions that have some larger numbers. So I'm going to start off the same way I always do, by copying down the first fraction, and I'm then going to multiply it by the reciprocal of the second fraction. Now, multiplying the numerators out with each other, I'm going to get 360, and multiplying the denominators out, I'm going to get 1,620. Now, I can start to divide this quickly by seeing that each is divisible by 10 because they end in a 0. That's going to then quickly bring the fraction down to 36 over 162. I still have some work to do here, so I'm going to start off by dividing each by 2 because I can see that they are divisible by 2, because they're both even. That is then going to take the answer to 18 over 81. And then I can finally see in my last reduction that these are each divisible by 9. So I'm going to divide each by 9, and I'll get my final answer of 2 over 9, which is in fully reduced form. Now, I believe a more efficient way is to simplify before I multiply. And how do I know that I can simplify first? Is that I'm looking for numbers that would divide into both numbers in the numerator and denominator. So for instance, 5 would divide into 30 and 45, and 6 would divide into 36 and 12, as an example. You could also do smaller numbers, but the larger numbers you can find, the less steps you're going to have. So if I write each of these numbers in factored form, now that they're in factored form, we can start looking to divide to 1. So I know that this 5 and this 5, they would divide to 1. This 6 and this 6, they would divide to 1. And this 6 and this 6, they will divide to 1. And now I can multiply out in the numerator. I can see that I have a few 1s and a 2, which makes a 2. And in the denominator, I have 3 1s again and a 9, and they multiply to 9. One last example. What happens if we have fractions inside of fractions? Well, we can quickly see that this is 3 over 4, and then this middle is going to be the divide sign. So if we write this as we have been, this will be 3/4 divided by 5/12, and then I can just continually do what I've done all video and multiply by the reciprocal of the second. I can then see that the 4 and the 12, they will each divide by 4, so I could factor the 12 into a 4 times 3. I can then do my divisions, so 4 and 4 will divide to a 1, and then I can just multiply out my numerator, so 3 times 3 is going to be 9, and in the denominator, 1 times 5 is 5.